Hello everyone. So in this video, I want to go over how to do another stoichiometry problem that goes from volume to mass. Now this problem is a reaction about aluminum and sulfuric acid. Now the question for you is, how many grams of aluminum is needed to react completely with sulfuric acid to produce 820 milliliter of hydrogen gas? Assume that all measurements are done at STP. Now knowing that these measurements are done at standard temperature and pressure, we can use the conversion factor, that is 1 mole occupies 22.4 liter of gas. So let's go ahead and use that. So first of all, I want to always find my given. And I can see that my given is 820 milliliter of hydrogen gas. So right there is my given. And what I want at the end is that I want grams of aluminum. So I want that. Okay, let's see what is our strategy. The strategy that I have, I want to first convert a milliliter of hydrogen gas to liter of hydrogen gas, because remember the conversion factor is that 1 mole occupies 22.4 liter of gas. Now, if you don't have your volume in liter, that could be a problem. Your calculation might be off. So our first step is to convert the milliliter to liter so we can use this conversion factor to our favor. Now, after we have converted to liter of hydrogen gas, we can then use that conversion factor to convert liter of hydrogen gas to mole of hydrogen gas. Then, using our trusty balanced chemical equation, we use the mole ratio to convert H2 to mole of aluminum, which is what we want. But wait, we don't want mole of aluminum, we want grams of aluminum. So then using the molar mass, we can convert mole of aluminum to grams of aluminum. So there's my strategy. Let's see how this calculation actually sets up. So we always start with our given, which is 820 milliliter of hydrogen gas. I want to multiply it by a few different conversion factors here. First of all, I want to convert milliliter of hydrogen gas to liter of hydrogen gas, and I do so by putting 1000 milliliter of H2 at the bottom because I want the milliliter to cancel out. And then note that 1 liter is 1000 milliliter. So at the top, we put 1 liter of hydrogen gas. We're done with our step 1 in the strategy. Step number 2, we got to convert now liters of hydrogen gas to moles of hydrogen gas. And we used our trusty conversion factor there with a 22.4 liter of H2 per mole of H2. So we put liter of H2 at the bottom to cancel out with mole of H2 at the top because that's what we want to keep. Moving on to using our balanced chemical equation to give us our mole ratio. So we want to convert moles of H2 to mole of aluminum. We have 3 mole of H2 right here, 3 mole of H2. Then to moles of aluminum, and we have 2 moles of aluminum right there. Then the last step is to use the molar mass of aluminum to convert moles of aluminum to grams of aluminum. And we put mole of aluminum at the bottom because we wanted to cancel out, and grams of aluminum at the top because we wanted to keep it. Then we punch it in the calculator, just making sure that everybody cancels out and we only left with what we want at the end. We have grams of aluminum needed, keeping in mind significant figure. Our given has 2 significant figures, so our final answer must have 2 significant figures. So that's it for this problem. It's only a matter of adding that little extra step of converting the unit to one that we see in the conversion factor. So we can use that conversion factor to our advantage. Okay, that's it.